Okay, so now what we're gonna do is we have understood about various things like we started with something like vectors, we went to matrix, and then we basically saw basically much more in depth of matrix, that how it works. Now what we're gonna do, these are going to be in fact a very important topic when from the machine learning point of view. Let's say if I have to define now a line, I'm not no more talking about from a vector point of view. So a line is very simple, right? So you will always say that okay, a line is this is basically nothing but a line. Now if I ask you now, can you recall me the equation which you used to use for defining this line? So you would say that my equation is going to be y is equal to mx plus c, right? Where m is nothing but your slope and this c is your intercept, right? So this is basically what you define. Some more people can also say that I can define this line as ax plus by plus c is equal to 0, and if you actually interchange this equation you can turn it exactly in the same manner. Means you can always say that y is equal to minus c by a minus a by bx, right? So this is nothing but this is your c component, this is basically your m component, right? So you can always define it in this manner. Now let's define this equation which I have just written here, which was like let's say if I have to define it for more than one equation line, like till now what I was doing is I was just saying that okay, ax plus by plus c is equal to 0. Let me give a more appropriate representation for it. If you look at this, I can better represent it in this form so that we can have kind of a homogeneous kind of structure, ax1 plus bx2 plus c is equal to 0, right? So now I'm just representing my y as x2. Now instead of calling it as a, b, c, how about if I represent it from a, b, c to w naught, w1 and w2, something around that. So how about if I say that I have a w naught plus w1 x1 plus w2 x2 is equal to 0. This is another representation which is coming in a 2D plane. So now we are no more talking about a line, but instead we are going to talk about a plane. So my plane is gonna look different, right? So this is, you can visualize in a 3D world. 3D world you can think of in front of your eyes. You do have a plane being available to you. Now the question is, can I expand this into more than 2 dimension to 3 dimension or to n dimension? Yes, you can very well do that. Now in a 3 dimension, if I have to define the same thing, I can say w1 x1 plus w2 x2 plus w3 x3 plus w0 is equal to 0, and this basically talks about an equation of plane as well. Okay, so this is coming in a 3D plane. Now if I have to define the same thing to my n dimensional plane, now this n dimensional plane we can also denote it as hyperplane. I can also denote it as hyperplane. Now this is quite easy to represent, right? So I can, with all the magic which we have learned, we can say w0 plus w1 x1 w2 x2, and we will keep on doing it till the time we have wn xn, right, is equal to 0. So this is going to become my equation of line. Now I can also represent the same thing as w0 plus, I can go from y1 to n and I can say wi xi is equal to 0. I can plug in the same values and I will get this. Now if you recall, my vectors w is always going to be a column vector. So it's gonna be like I have w1, w2 till wn, right? And at the same time my vector x is also going to be a column vector. This is going to be x1 till xn, right? And what we are doing in this last equation, in the last equation we have written it like w0 plus I is equal to 1 to n wi xi is equal to 0, which means that I am saying w1 x1 plus w2 x2 plus w3 x3. From the matrix multiplication what we have learned, definitely this is what n cross 1 and this is also what n cross 1. I cannot multiply both of them, but what about if I transpose this w? So if I have to transpose this W, what we have learned from the last section, this is going to become W1 till Wn, and my x will remain this. Now if I multiply this thing, so if I say now W0 plus, and now if I define this value as Wt x, means I'm taking the transpose of x into x is equal to 0. Is it going to be anywhere wrong? No, this we are perfectly fine with this. So we can always define our values in this particular format if we want to basically define all these things up. Now one more thing, if my line or a plane, whatever it is, if it is passing somehow through origin, then my W0 is going to become 0. So in that case, I can always represent W transpose X is equal to 0. Very interesting equation what we get, just that if we change or consider the line or plane passing through my origin, passing through my 0, 0 part. So we just understood a very interesting fact that if my W0 is equal to 0, means it is passing to origin, this is going to be this equation. Otherwise, my equation is gonna remain like this. Okay, this is going to be my equation elsewise. Now, let's talk about some more interesting things with respect to now this plane. So let's say I have a plane and I'm gonna denote with the line pi. Now let me tell you this part, this is going to come a lot while talking about logistic regressions and all, SVM and all that. So please listen to this part very carefully, because at that time I'm gonna actually going to use this concept of pi plane coming with these equations, and also you have to be very careful. Let's say this pi plane is passing through origin 0, 0, and I have a vector W which is a unit vector, let's say, and this is 90-degree perpendicular to this. Now in this case, since my equation of my plane is Wtx is equal to 0, because it is definitely passing through my origin. Now in this case, we can also define my value to be as W length of this, length of x cos theta, okay, is equal to 0. Now here theta is 90-degree. So in this case, cos 90 is going to make this whole thing as 0, right? That's how we are getting this equation. So we can always say for any x, x1, x2, any vector which is exactly falling on this plane, and I have this vector W, then their product is always going to return me the value which is going to be 0. Okay, so keep this in mind while basically you are solving all these problems. This is quite interesting, right? So we got to a point where now we are able to identify that how my equation is coming to 0. So what all we have done till now, right? So if you basically look at this, we got to an equation, and using that equation we basically we are able to define my from the line equation to a plane equation, and so on. Now in the next lecture I'm gonna talk about some more interesting things in terms of, if I have, this is just a plane, but what about if I have points above the plane and the lower side of the plane? If I look at, can I get some very interesting characteristic there which can differentiate whether these pointers above the line, which is below the line, something like that. So let's do this in the next lecture.